In this video, we're going to look at gases and their relationship of their volume and temperature. This is called Charles's law. And Charles's law states that the temperature of a given amount of gas is directly proportional to its temperature when the pressure and the number of moles is held constant. And so we can see that expression here of volume is proportional to temperature, and we can write this in an expression where volume is equal to proportionality constant times temperature. If we rearrange that equation and have a gas that is combined with a constant pressure and number of moles, we can rearrange that equation to have the volume divided by temperature equal that proportionality constant. And if we look at a particular condition, like condition number 1, the volume at condition number 1 divided by the temperature at condition number 1 should equal a proportionality constant. If you look at that same gas at a different condition where you have a different volume and that temperature at that particular different volume, and you divide that into the volume, you should get the same proportionality constant. If that is true, then you should be able to set these two conditions equal to one another, and this is the equation V1 over T1 equals V2 over T2, and this is called Charles's law. So let's use this equation in a problem. It says a 2.5 liter volume of hydrogen gas is measured at negative 196 degrees Celsius. So let's just kind of take that information here and say this is condition number 1 and is warmed to 100 degrees Celsius. So we know that that already is part of condition number 2. It says calculate the volume, that's our unknown part of condition number 2, of the gas at the higher temperature, assuming no change in pressure and the amount of that gas. So we're going to take our information out of that equation. Volume 1, temperature 1. Volume 1 is 2.50 liters, temperature negative 196 degrees Celsius. Volume 2 is unknown, and temperature 2 we know to be 100 degrees Celsius. Now, anytime we're using temperatures in gas law equations, let's make sure that we note that you cannot use degrees Celsius. So we need to move everything to Kelvin. So we're going to add 273 to each Kelvin value, and that's going to give us a value of 77 Kelvin for T1 and 373 Kelvin for T2. So now let's plug these values into our equation. V1 over T1 equals V2 over T2. And so we have 2.50 liters over 77 Kelvin equals V2, our unknown variable, over 373 Kelvin. We're going to solve for V2 by multiplying both sides by 373 Kelvin. That will cancel out on the left, Kelvin cancels out on the right, and we just plug all of our values into our calculator and I get something along the lines of 12 something in liters, but we're going to make sure that that's 2 sig figs because of the 77, so it's 12 liters as our value. So in this video, we've looked at a relationship between volume and temperature. This gave us this equation here called Charles's law, and this is how you use it.